Imagine you're a scientist at Google DeepMind trying to accurately predict the structure of hundreds of millions of proteins from their DNA samples. Now, this is a daunting task, even though it's already been done back in 2020. You have over 16,000 computers to work with, but still 100 million data samples is just too much to handle. So what do? Now, you don't need to be in Google DeepMind to have too much data to handle. I've actually encountered problems just like this in many machine learning projects that I've worked on, and solving them isn't as straightforward as you might think. So today, let's talk about data batching. Think of the data you feed your model like a big pizza pie. How would you eat it? Would you shove it all in one bite? I hope not. Though there are some models like Naive Bayes, Random Forest, and several others that are fine with eating everything in one big bite, the really powerful models like neural networks really prefer to eat them in small batches and then gradually learn patterns from each batch. But what does that even mean? This is a lesson I learned the hard way. Early in my career, I tried to train my first image classification model on a simple dataset called CIFAR-10. It has 50,000 color images in 10 classes, and it's considered to be pretty simple for beginners. Now, 50,000 might sound like a lot, but my laptop actually loaded it without any problems. The issue came when I tried to train my model, and my laptop just froze and crashed like 3 times in a row. I remember being so frustrated because I was so excited to train my first model, and this silly bug was getting in my way. It turns out that during training, your model takes up way more memory than the original data does, and this is what was crashing my computer. So what's the solution? The idea is pretty simple. You just take the data and break it up into smaller batches, then feed it into the model one batch at a time. Pretty simple, right? Well, no. If you want to train your model in this way, and many times you really don't have a choice, there are 4 things you need to keep in mind to train your model properly using these batches, or mini batches as they're sometimes called, which I'm going to show you right now. Let's go back to that pizza analogy. Unlike pizza, your data is usually made up of many different populations. You can kind of think of this like different toppings on the pizza. And to train your model properly, you need to give it a mix of these toppings in each bite. This is if you want to get the very best results. This is actually not so hard, and I talked about it in my previous video, link below. The idea is to shuffle your data before you cut it into slices. And this should take care of the first issue of mixing your data, but what should you do if you have almost no samples from some of your populations? Think of it like 5 olives in a pizza of 1,000 slices. This is a problem I've actually encountered many times in the project that I've worked on, and I'm not sure you're gonna like the solution. Ideally, if you can give your model a more or less equal mix of all the different populations you have in each training batch, you're probably gonna get the best results across the board. So what you need to do is lie a bit to your model and pretend like you have more data than you actually do have for these underrepresented populations. What you do is you make copies of the same data samples from these populations until you have enough to match the data from the other populations. You can actually achieve this through an elegant solution called weighted sampling, and I'll dive deeper into this in a future video, but the idea is that you sample more often the same data samples from these underrepresented populations and sample less the populations that you have more data for. And this sort of equalizes out until you get the same mix for all the populations. So if you have any data imbalance issues, definitely give weighted sampling a try. Okay, so if you take care of these first 2 things, you're probably going to get pretty good results and your model is going to train well. However, your computer might still crash if you have too much data. At this point, you probably see that I explain things a bit differently than most people. So if you enjoy this content, like the video and subscribe to my channel. Remember that scientist from the beginning of the video, the one with too much data to handle? What should you do if you have so much data that you can't even load it into memory? Let's change the analogy from pizzas to cookies and just roll with me for a sec. Think of each cookie being a sample of your data, and your cookie shop being the program that needs to serve all these cookies to your model and give your model a place to eat them. And by eating the cookies, I mean letting the model train just a little bit on each batch of data. But what should you do if you don't have enough cookies in your shop to feed the model? Well, in this case, you're gonna need to go to the bakery to get more cookies. And in this analogy, the bakery is where all your data is stored. This can be like a hard drive or some cloud storage. But there's a problem. Going to the bakery takes time, and you can only carry one cookie in each run. So what should you do? To handle the first issue of grabbing all the data, you just parallelize all the process. You get multiple workers to do the work for you, and they handle retrieving and preparing the data in each batch for your model. They all work in parallel, so this mostly solves the one cookie at a time problem, assuming that you have enough cores in your computer. Now, that's nice and all, but preparing each batch still takes time. So how do we solve this? Well, once I ask the next question, I'm pretty sure you're going to get the solution right away. Let's ask the question, should you wait for the model to finish eating before getting the next batch? Of course not. It's a total waste of time if you know your model is anyways going to need more batches. So the second part of the solution is called prefetching. This is where you start fetching and processing the data from the second batch even before your model is done with the first batch. Pretty smart, right? Even scientists at Google DeepMind use these kinds of tricks. Now, if you want to see how this works in practice, there's actually a great problem in deepml.com that can help improve your understanding. This is a great website with lots of machine learning coding problems. And in this problem, you're going to handle batching, not the prefetching and the parallelization part, but only batching. However, I do think that it teaches you a lot. But before I show you the solution, try to pause the video and think how you would solve it yourself. The idea goes like this. You have a dataset of say 10,000 samples and you want to feed the data into your model at batches of size 32 or so. You assume your data is already shuffled and pre-processed, and all you need to do is handle the data batching. So what you need to do is take these batch-sized slices of your data and turn your data into a list of batches. Then the code down the line can just iterate through the batches and feed them into your model to train it. And in this problem, you need to support both cases where you either do or don't have labels for your data samples. However, like we said, this problem assumes that the data fits inside the memory, so you don't need to handle any of the parallelization or the prefetching. So to recap, batching or mini batching is a way to train your model on mini batches of the data without overloading the memory of your program. To do this effectively, always remember to first shuffle your data, balance it out using methods like weighted sampling, parallelize the fetching and processing of your data, and prefetch your data to kind of smooth out the entire process and make it more streamlined. Now, the nice thing is that all kinds of packages like PyTorch and TensorFlow, they kind of handle this under the hood in their data loaders. So you just need to figure out which arguments to change. So that's it about mini batching. I hope you learned something today, and one thing we didn't cover in this video is how to choose the right batch size. That's going to be a topic for a future video, and I'll see you then.